guys, so we're going to be talking about binomial theorem. So there's something called Pascal's triangle, and that's this beautiful pyramid right here. So if you take a second, just pause the video and try to see if you can figure out what the next row is. See if you can figure out what the pattern is. All right, so you're back. Hopefully you've kind of seen what the pattern is, where it always starts off with like 3 little ones here, and then you add these to get that 2. So then 1 plus 2 is 3, and then this 2 plus 1 is 3. So every row is going to start with a 1 and it's going to end with a 1. So then you'll see we have the 1, 1 plus 3 is 4, 3 plus 3 is 6, 3 plus 1 is 4, and then it ends with a 1. So if I wanted to create this last row, or the next row, goes on forever, I'd start with a 1, 1 plus 6 is 7, 6 plus 15 is 21, 15 plus 20 is 35, 20 plus 15 is 35, 15 plus 6 is 21, 6 plus 1 is 7, and then it goes to 1 again. So as you look at this, I want you to kind of notice that, okay, everything starts and ends with a 1. There's symmetry. So 1, 3, 3, 1. 1, 4, 6, 4, 1. So it goes up and then it goes back down. Every other row has like a repetition here. Okay, and the other ones, they peak and then they go back down. So we're going to be doing binomial expansions, starting with Pascal's triangle and then moving to the binomial theorem. So basically, instead of having to write out 2p plus q 5 times, that'd be a lot. We'd have to do foiling 5 times. It would get very messy. There'd be a lot of room for error. What we're actually going to do is we're going to use Pascal's triangle. Now there's a lot of patterns that happen here, so we'll kind of see those as they come up in a minute. So this 5 right here, because that exponent is 5, I would use the row that starts with a 5. So what this is telling me is this is actually the coefficients for my binomial. So I'm going to write down this 1, 5, 10, 10, 5, 1. So I'm going to end up with 1, 2, 3, 4, 5, 6 different terms here. So the way that we're going to do this is I'm going to go ahead and say, okay, my first term starts with a 1. And then this is like my part A right here. So I'm going to take that 2p and I'm going to take it to the 5th power. And then I'm going to take this q right here, that's my second piece, and I'm going to put that to the 0 power. So something else that we want to realize is because this is a 5 here, my exponents are going to add up to a 5. So if this is a 5 and this is a 0. Now if you look at the printed out online notes, there's a bunch of notes about them. It kind of shows you an expansion and how it works. I'm just kind of walking you through it right now. Then we take plus, my next coefficient is 5. So I'm going to take that 5 right here. And then I'm going to take this 2p. Now what happens with this first term, this a term right here, is the exponent goes down by 1. So at first it starts as 2p to the 5th, which matches this 5. Now it's going to become 2p to the 4th. And my q is going to go up. So I'm at q to the 0, and then I'm going to go up to q to the 1st power. So as you look here, a 4 and a 1, that adds up to that exponent of 5. Then I'm going to keep going and say, okay, my next term is 10. So plus 10. And then I'm going to take this 2p, and this 4 is now going to drop down to a 3. And this q is going to go up to a squared. Again, that 3 and that 2 are adding up to be a 5. So I'm going to keep going. My next one is a 10. And then this 2p is going to drop down again. So this 3 is going to become a 2. And this q is going to pop up to a 3. So it keeps on going up. Again, 2 plus 3 is 5. Got 2 more here. I've got this 5 coefficient. My 2p is going to go down to a 1. And my q is going to go up to a 4. There it is again. 1 plus 4 is 5. And then I'm going to end with a 1, running out of room here. So we're just going to squeeze that in. My 2p is going to go down to a 0. We're out of those. And my q is going to pop up to a 5. So we know that we're done now because I've ran out of p's here. And I popped up to my maximum number of q's, which is 5. It's going to end matching that also. So now what we do is we just kind of multiply this all together and we do all the math. So I'm going to take 2 to the 5th, which is 32. Q to the 0 is just 1, and I have this coefficient of 1. So I multiply all those together and I get 32, and then I have a p to the 5th, and I've got no q's. And I'm going to take a 5 here. A 2 to the 4th is 16. So 5 times 16, that's going to give me an 80. And then I have p to the 4th, and I have q to the 1st power. So there's my q. And then I'm going to go ahead and take a 10. And 2 to the 3rd is 8. And so there is going to be an and 80. And I have p to the third power, and I have q squared. And then I'm going to have this 10, and 2 to the second is going to be 4. So when I multiply those together, I'm going to get 10 times 4, which is 40. And I have p to the second and q to the third. Last couple here, I'm going to have 5 times 2 to the first, which is just 2. I'm going to end up with a 10, and I have 1p, and I have q to the fourth. And then when I get to this last one here, 2 to the 0 is just 1. So I'm ending up with 1 times 1, so I don't need to write that coefficient. P to the 0 is just 1. So we're all out of p's. There's no p's in my final answer here. And then I'm going to have q to the fifth. So this is using Pascal's triangle. So Pascal's triangle gave us these. In order to get those numbers, you would have to go through and you have to write out the entire triangle. So if you understand the pattern of how to create the triangle, then you're going to be good to go on this. Now, if I asked you for like the 7th or the 8th pattern, well, then you got to make all of those coefficients, and you got to just be careful not to make a mistake. Now, the binomial theorem, if we think about combinations, sorry, I lost my word. If we think about combinations, that's going to actually help us create those coefficients. So this binomial theorem here, if you look at it, it looks very complicated, but let's just walk through it for a second. So if I have some binomial to some power, just like I had this a term and this b term to the 5th power. Okay, this NC0, if you type anything into your calculator, if you type 5 choose 0, you're going to get 1. So this is going to give you the first coefficient of your Pascal's triangle. So this is going to always be a 1 because look, in Pascal's triangle, all those coefficients were always a 1. So as we look at this binomial theorem gives us the coefficients. Okay, that's what's happening here. So let's look at the pattern. Let me zoom in a little bit for you. There we go. Sorry, I hope I'm not making you dizzy. Come on, focus here. Come on. Jeez. Okay, there we go. Sorry. So this is going to give us that 1. And now look, a to the nth power. Well, remember when we were doing that 5th expansion, my first term had that 5th power, and that b, that second term, had a 0. Remember, those have to add up to be whatever this exponent is. Then here, n choose 1. So if I had 5 choose 1, try it in your calculator. 5 choose 1 is going to be 5. Anytime you have a number and you choose 1, it's going to be itself. Well, that goes back into the Pascal's triangle that it's starting with that first number. And then look what happens here, a to the n minus 1. Well, remember, we took that p exponent and we went down 1? That's all that's happening here. And then b to the first power, right? We took that q exponent, we had 0 q's, then we went up to 1q. That's all that's happening here. Okay, so it's just the pattern. So you really have to understand the pattern that your first exponent is always going to be decreasing and your second exponent is always going to be increasing. Also noticing that your exponents are always going to add up to whatever the original binomial exponent was here. Now, how do you know that you're done? So you just keep on going however many times until you get n choose n. So once you get this match right here, 5 choose 5, 6 choose 6, 7 choose 7, whatever your expansion is, that's one thing that's telling you you're done. Second thing that's telling you you're done is, hey, look, I'm out of that first term. I went all the way down to 0. And the last thing that's telling you you're done is that you've maxed out that second term. So if we're doing a 5th expansion here, we're going to end up with a 5. If we're doing a 6th expansion, we're going to end up with a 6. So let's go ahead and try one of these. Okay, where we're going to expand this using the binomial theorem. So rather than going through and figuring out what Pascal's triangle are and getting what those coefficients are, we're going to go ahead and use that binomial theorem and we're going to practice finding it. So because this is an 8, I'm going to start with 8 choose 0. Okay, so 8 and 8 always starting with choosing 0. Then I'm going to take my first term, which is an x here. I'm going to put it to the 8th power because that's an 8. And then I'm going to take my y here and I'm going to put it to the 0 power. Because you always start with none of these. Plus 8 choose 1. And then my exponent is going to go down from an 8 to a 7. And my y is going to go up from a 0 to a 1. We'll do it again. 8 choose 2. So we're going up here. And then I'm going to have x to the 6th and y squared. Look at my exponents. 8 plus 0 is 8. 7 plus 1 is 8. 6 plus 2 is 8. It's all very consistent. It's always adding up to this original power. So we're going to keep going. 8 choose 3. x to the 5th, y to the 3rd, 8 choose 4, x to the 4th, y to the 4th, 8 choose 5, x is going down to 3, y is going up to 5, 8 choose 6, x is going down to 2, y is going up to 6. I've officially ran out of room, so we're going to keep down here. 8 choose 7, x is going down to 1, y is going up to 7. Then last, 8 choose 8. So 8 choose 8, I know this is my last one because I'm ending up with that match. I also know it's the last one because I'm out of x's, and I've got y to the 8th. All right, so now we're going to start typing this into our calculator. So you're literally going to type in 8 choose 0. If you need to see that, okay, 8 choose 0, there it is, 1. If I had any numbers here in these parentheses, I would take those to the exponents, okay? So we're just basically finding those numbers for our coefficients right now. So then I'll do that 8 choose 1, and I'm going to get 8. If I do 8 choose 2, I'm going to get 28. If I do 8 choose 3, 56. 8 choose 4, 70. 8 choose 5, 56. Oh, look what's happening. 8 choose 6, 28. 8 choose 7, 8, and then 8 choose 8 is 1. So you can see how we talked about with Pascal's triangle, how those coefficients go up and then they go back down. So we're seeing that same pattern here. So we go ahead and write our final answer. We're going to have a 1, an x to the 8th, and then no y. So I just have this x to the 8th here. Plus 8, there's no other numbers to multiply with, an x to the 7th, and a y. Plus 28, x to the 6th, y to the 2nd, plus 56, x to the 5th, y to the 3rd, plus 70, x to the 4th, y to the 4th, plus 56, x to the 3rd, y to the 5th. So I'm taking these right here. Plus, there's my 28, x to the 2nd, y to the 6th, plus 8, x, y to the 7th, that's this term here. And then last but not least, plus, I've got 8 choose 8 is 1, don't have to write that, x to the 0, all out of x's, and I've maxed out my y's with a y to the 8th. So when you're typing these into Buzz, guys, you're going to type in, each box, and it'll tell you if there's any extra boxes, and you're just going to put none of those extra boxes. So each term goes in its own separate box. All right, let's go ahead and see if we can knock this one out real quick. So it's got a subtraction sign, so we're just going to have to make sure we're careful with our signs. So I'm going to go ahead and say, okay, I'm going to do a 4 choose 0 because it's a 4. Then I'm going to take 3x to the 4th, and I'm going to take negative 1y to the 0 power. So I'm going to think of that as negative 1 just so that I can watch my signs. Plus 4 choose 1 going up there, 3x to the 3rd power, and negative 1y to the 1st. Again, look, 4 plus 0 is 4, 3 plus 1 is 4. Keep going, 4 choose 2, 3x to the 2nd, negative 1y to the 2nd, plus 4 choose 3, my 3x is going down to the 1st, my negative 1y is going up to the 3rd. And then, last but not least, 4 choose 4, and 3x is going down to 0. Oh, running out of space. How is that even possible? It's only 4 terms. And negative 1y to the 4th. So as we look at this, I don't know why it's so grainy. As we look at this, we're typing this in our calculator. So 4 choose 0 is 1. 3 to the 4th is 81. And then negative 1 to the 0 is 1. So we're going to think about multiplying all of that together to give us an 81 and an x to the 4th. No y's. 4 choose 1 is 4. 3 to the 3rd is 27. And then negative 1 to the 1st is negative 1. So now I'm taking 4 times 27 times negative 1. That's a negative 108. X to the 3rd, and now I have a y. 4 choose 2 is going to be 6. 3 squared is going to be 9. Now negative 1 to the 2nd power is going to be a positive 1. So now that's going to be a positive 54x squared y squared. And then 4 choose 3 is going to be 4. 3 to the 1st is 3. Negative 1 to the 3rd is negative 1. So now I have a negative 12x y cubed. And then finally, 4 choose 4 is 1. This becomes 1, and negative 1 to the 4th is 1. So I have just y to the 4th. Now be careful when you type this in. You're going to want to make sure you type that negative in because separated by pluses.